Okay, so we're going to go ahead and do example 6, and we want to condense into a single logarithm. So for the first one here, we're going to look at this right here, and we can do the power rule, and the power rule here for that 1/2 and that 4 out in front. So for part A, I have log of x to the 1/2 plus log x minus 4 to the 4th power. And then now I have the sum of two logarithms, so now I have the product rule I can do of log x to the 1/2 times x, do this in parentheses, x minus 1 to the 4th. And if you want to, you can write this as log square root of x times x minus 1 to the 4th power. Either one's fine. I believe you're in my math lab will accept either one. Again, part B, I have this right here. So remember, we want to have our first term have leading coefficient 1. To do that, we move the 3 up here to the power. So it becomes the natural log of x plus 7 to the 3rd power minus the natural log of x. Now we have the difference of two logarithms. That would be the quotient rule. So the natural log of x plus 7 to the 3rd power over x. And if you need to, you can put parentheses around here or brackets on here. So all that is your quotient. Okay? And then part C, just right up here. I'm going to go ahead and move all the powers up to here. I get log base b x to the 4th minus log base b 6 squared minus log base b y to the 1/2. And again, make these be through all your bases. Okay, this right here can be changed to 36. So I get log base b x to the 4th minus log base b 36 minus log base b y to the 1/2. Now here we're going to be really careful. There's a little trick here. Notice how there's two minus signs here, and I don't want to do the quotient rule twice. So what I'm going to do is I'm going to go ahead and factor out that minus sign. So I'm getting log base b x to the 4th minus, in parentheses, log base b 36 plus the log base b of y to the 1/2. Because I do that, now I can use the product rule right here. That gives me log base b x to the 4th minus log of 36 times y to the 1/2. And now I have just these two things to worry about. So now I have log base b x to the 4th, let me do the quotient rule, 36y to the 1/2. And you can do that, or you could write log base b x to the 4th over 36 times square root of y. Either of the answers are acceptable. Okay, that's a difficult one. There's a little trick here. You know, you have two minus signs. You don't want to have a fraction and a fraction. What you do is you go ahead and factor out that negative sign, and then you have not so many of those fraction signs. That's the big key step right there. Okay, go ahead and pause your video and go ahead and do the problem on your own, and then I'll go ahead and restart the video. Okay, here are the answers to the on your own problem. Okay, and make sure you understand how to do part C, because that's going to be on your exam or your next exam. Okay, the last thing we're talking about is the change of base property. And on your calculator can do log, which is the base 10, the natural log, which is the base e. But your calculator cannot do any other bases. So to do that, to figure out those values, we can use logarithms or common logarithms to change it over. So something called the common logarithm. And you can memorize the formula, or you can just write it on your note card. The log base b m over, oops, my bad, just log base b m equal the log of m over the log of b. So you can use your calculator to type in these two values right here. You can also use the natural logarithm. And you're going to do log base bm is going to equal the natural log of m over the natural log of b. And again, you can use either one of these to figure out the value of any logarithm with any base. So example 7, here I want to find the log base 5 140. So I'm going to use common logarithm, so I'm going to use this right here. The log of base 5 140 is going to equal the log of 140 over the log of 5. And that's what you're going to type in your calculator. Right there. So I get approximately, when you type in your calculator, make sure you type this in parentheses and then in parentheses, or just make sure that you're not taking the log of 140 over 5. Go ahead and type in a calculator and you should get approximately 3.070. And how can you check this? Remember, this is just your exponent. This right here is your base. This is going to be your exponent, and it should equal 140. Well, since we rounded it off, it's not going to be exactly 140, but it should be very close. So let's check this. The 5 to the 3.070 should be approximately 140. In your calculator, what I get is 5 raised to the 3.070. I get 139.9. Again, it's a little bit off because I had to round this off. Okay. Example 8, let's do the same example. This time we're just going to use the natural logarithm. So we do the same problem. And we use the natural log. The natural log of 140 divided by the natural log of 5. Okay, type in your calculator, you should get the same answer, approximately 3.070. Okay, so on your own, go ahead and do these two problems and read the directions carefully. On the exam, we'll have one where you use the common logarithm and one with the natural logarithm. Okay, so when you use the common logarithm or the natural logarithm, you should get about 4.022. And then I'm going to check that. Remember, 7 is your base. That's your exponent. And it should be approximately the 2,506, which it is. Okay, that's the end of this section. If you have any questions, make sure you email me.